Okay, great. Let's start. As I already announced, there is a recording on this laptop to record the slides and the audio, so we can at least give it to the other colleagues which are not here as well, just that you know about it. So be careful about the questions you might ask. Probably I will name you as well, so that we have the question and the names. Okay. My name is Nils. Hopefully most of you might already know me. If not, I started at the Haufe Group 2.5 years ago in the editorial department. Then at least by beginning of this year, so I went to the CTO office as lead architect to enable our cloud strategy a little bit. And shortly being there, at least, I moved over to Haufe-Mantes, to the Mission 1 as director of engineer. And I'm doing nearly the same thing like I did in the CTO office, no, just only for the Humantis term, but it is the same story. Today, I want to at least take you a little bit on the journey which I had during the last 6 months. So we are just talking about the last 6 months, and also at least give you a little bit insights of our cloud native journey and why, for example, we decided for replacing Kubernetes through the Amazon AWS Fargate service, and what kind of benefits at least it leveraged for us, but also for our customers. Normally, before I start the presentation, I ask who knows Haufe. This is hopefully something we can at least skip here, but I would introduce a little bit about the Haufe talent management, if this is going to work. Yes. Here we go. Quickly about the Haufe talent management, because I know the situation, mostly sitting in, I don't know, the auditorium, looking on some technical slides and asking myself, what the hell is this product about? I never heard about it, as Haufe is not just a single product company. It might be helpful for you as well to understand what is the Haufe talent management. The Haufe talent management has the aim to enable employees, but also companies, during the life cycle of an employee within the company to at least be as successful as he could be. So normally at least those life cycles start with the recruitment, over the onboarding, then at least it is somehow with engagement, feedback, so how can we leverage the most out of it? And then in the end, at least it is also the later stage, the offboarding. And for all of those different stages, we are serving, or we want to serve, different products. And today at least we are going to focus on 2 of those products. The one is Haufe Instant Feedback. Haufe Instant Feedback is a mobile application with an administrative backend for managers to at least allow new employees to get in those applications as well. What is the intention of Haufe Instant Feedback? We want to at least establish and enable a feedback culture within companies or within the companies of our customers, so that they at least can leverage out everything which has to do with feedback. For example, at least it's not only about sharing feedback peer-wise, so from colleague to colleague, you can also at least share feedback based on appointments or meetings you had. So we can synchronize the calendar of the mobile app or of your mobile phone with our mobile app. And if the meeting at least is over, you can quickly at least say, okay, I want to get feedback from everyone which was in this meeting as well. And then at least you can improve yourself. For the Haufe Agile Heads, this is only a web application. There's not a mobile part for it, but it's a web application where a product owner, project manager, or whoever has money and can at least bring some ideas ahead. They can at least add some ideas on those platforms, say, I have an idea of a new product, of a feature or whatever, and I'm looking for someone who can contribute there with a dedicated set of skills. And at least on the other side, we're having all of those employees with the dedicated skills or with some skills where we might find some matches, and also at least people which can apply to those projects even if there might be not a match, but the person is interested in this topic or whatever. So that's at least the idea of Haufe Agile Heads. Now at least I want to quickly go through from self-hosted application to cloud-native applications. Because yes, when I also started 6 months back, I realized those cloud strategy isn't in the Humantis yet. So it was at least for me the first thing what I realized and also discussed with those people. What does cloud strategy mean and what is really cloud native? So looking on the time ranges, 2 years back at least, we already had the first version of Instant Feedback, which were developed by an external company. So we outsourced the development for it. The application is still hosted on Azure DE, which is also at least an issue for us because you all are aware of those Azure DE thing. So we have at least 2 months or 4 months probably left to really get our new application running on our new infrastructure. In 2018, at least, after we had the first customer and instant feedback, we realized, oh yeah, we need to further develop this application and also the backend to get better multi-tenancy, to get new features into it, to be better scalable. And that's exactly what started in 2018. And then at least 2019, when I also joined the Humantis, we took the next step, not only re-engineering the backend, also rethinking the architecture of the backend, because this wasn't cloud native. And I realized, wow, we will spend a lot of effort in the future in maintaining this infrastructure based on our own data centers. This is not that what we are looking for. So then at least we decided on the one hand side on the move to AWS, but also in the same situation, we also decided to say, and those approach with having 2 native applications, iOS and Android, is also not the best for us, because looking on what the customer is asking us for, it might go in a direction where we need twice the development effort to really get new features into it and also to maintain the application. So we decided in the same time to say, okay, we move to AWS, and we also replace those native applications through a hybrid approach. The same is for Haufe-Lexware. 2018, we also started there with the development, but also at least already in somehow terms with a microservice approach. So yes, we started to use Docker, which is obviously one of the best steps at the moment. But at least we were focusing for operating Kubernetes cluster on our own, in our own data center. And at least in 2019, same story, where I also said, okay, well, do we really want to operate a Kubernetes cluster by our own? At least when I started in the Haufe group 2 years back, we had the same situation of saying, yes, we are going in Kubernetes and also operating it by our own. Even if it was an AWS, it was just virtual machines we had there. It had nothing to do with a service. And I know how hard it is and how often you can fail at least with it. That's why I asked them as well, do we really want to operate it by our own? Or are we going within the cloud and making use of those services? And we at least agreed here, the same situation going into the cloud. The architecture in 2018, when we decided the backend re-engineering, but also at least when we decided to rethink the architecture, this was the actual approach which we had in place. So obviously it is not that old and it is quite a good approach. It is what you can see here, Kubernetes cluster with different services, also at least the stateful services are within the same Kubernetes cluster. We have some external services like an SMTP server and the one signal notification to send push notification out to our customers or to the mobile applications. That was the approach, which obviously is not that old, that we really need to rethink the architecture. But at least we need to rethink how we want to operate this. And then we started to move to the AWS and start to rethink one of those or partly a few of those services. To go a little bit more into detail, I have later a more detailed picture of the actual approach because we are sharing the same infrastructure or at least the same architecture of the infrastructure for instant feedback as well as for the Agile Heads. For Agile Heads, same story, just different picture. So also based on Kubernetes, we are at least having 2 Kubernetes cluster also because when you're not in the cloud, you need to deal with disaster recovery as well. That's why on the right-hand side, we have the disaster recovery. On the left-hand side, the production Kubernetes. We had different namespaces. Everything was defined quite well. We had a kind of different services. The decision before I joined was also there to say we have a dedicated Kubernetes cluster for our databases, which was for me also something quite new. And I was wondering if this is really the best approach, because then you're not operating only one, you're operating 2 Kubernetes cluster, and you also need to deal with the traffic between those. But this was the decision so far. And we have here at least the same picture. So we decided going from the left to the right into the cloud native and leaving on-prem solution behind us. To go quickly into the detail what we see in those architecture. What did we change? So it all starts with the user, which wanna has somehow access to our application. Doesn't matter if it is the mobile application or if it is the administrative backend or the web page of Agile Heads. Yes, we have a Route 53, so whatever domain it might be, how the user can access our cluster. And then at least we have load balancers in place, we have an API gateway in place, we have also CloudFront in place for the CDN, where at least we can decide what kind of information is he requesting. If it's static, it's going to the S3 bucket. If it's not static, it's going to the API gateway. And through the API gateway, it's going directly to our at least EKS cluster with which we started. And in the back, at least, of this EKS cluster, we have some AWS services like the Elastic Field Service for sharing some data between different containers. The same with SQS. So we have an SQS for processing some messages or sending out emails and push notifications. And we also at least have our database in the back based on RDS. And to quickly show what the move is really about, I pointed those services out here. So yes, we really did the decision, and even this was something I also had a little bit of fight with myself. We replaced Kong through the Amazon API gateway. This was more the decision to say, what is the benefits we can get from Kong? And we saw a lot of benefits, but we also saw we don't need those benefits. That's why we said, instead of at least looking for benefits which we cannot leverage, we will stay with the easy solution. This was for us the Amazon API gateway. The next is Kafka. We replaced Kafka through the Amazon SQS. So message broking at least is now done by the SQS. The same is for OneSignal and also the SMTP. So we replaced OneSignal and SMTP, not as mentioned in the picture before, through SNS and SES. We recently skipped both and went through the Amazon Pinpoint solution, which is at least bringing both together. So you can at least per customer decide if you want to send an email or push notification, and you have a better customer engagement, let's say, like this with the Amazon Pinpoint. One of the highest impact and also one of the best changes, at least we did, is that we replaced our Postgres database inside a Docker orchestrated by Kubernetes through an Amazon Aurora service, which is also based on Postgres, which at least brings us a lot of benefits in terms of scalability, backup, disaster recovery. All of those topics at least are now a lot more easier for us to operate. And also, at least to mention this, and something at least I started 2 years back in the Haufe also with those serverless term, and I was quite happy hearing this today from Holger, that this might be not the worst choice. We also at least started to replace a few of those Docker containers through Lambda functions. Even thinking about instant feedback, where we have an API gateway, where the application, the mobile application, is requesting for informations or data. There is no need to at least combine your API gateway with a Docker container to get the information out of the Aurora database. It's a way easier to directly combine your Amazon API gateway over Lambda function to your database. And this is also in terms of scalability and performance a lot better. So we also started to rethink what kind of services do we really need, and why does those at least have to be in our EKS cluster.
Can I put a question?
Yes, yes.
You moved from Kafka to Amazon SQS.
Yes.
And so Kafka is able to store data in streams like for a long run. SQS not if I'm...
You can at least also define it there. So there are also in the SQS two types how you can define it. At least for us, it was not the requirement to store something on the long term. Because normally the only thing when we are using the SQS is for processing messages out. So for example, sending an email out or sending a push notification out, which should obviously be in a faster run than in a long run. With the conclusion, and I want to go into detail in a few seconds, that we said, yes, we replace EKS to Fargate. The funny thing really is, between the left and the right, there is not really a difference also beside that we at least having here the Fargate name, and on the left it is the EKS. But based on Amazon, there's not a huge difference between going EKS or going Fargate, as both are part of those ECS, Elastic Container Service from AWS, but the way how you orchestrate your application behind the scene is a really huge difference. So looking on those things, when you're thinking about Kubernetes, you really need to start to think about pods, daemon sets, deployments, secrets, and more one of those hardest like the PV and PVCs, how to really have persistent volume and persistent volume claims in your Kubernetes cluster. You need to deal with the autoscaler to scale your cluster accordingly to the workload. You need to deal with Kubernetes updates. Yes, this is a service, but still you need to at least click the update button and to be aware that you also update your worker nodes. You need to deal with access rights with the airbag, which is also something quite heavily. And at least this is only about the side of Kubernetes. Thinking about the integration into AWS services, it's getting way harder. Because how to integrate into RDS? Yes, you can at least get in RDS, you can share the credentials in a secret store, and then you can somehow access this over your application itself. That works, that's fine. One of at least the biggest issues we realized is the role-based access following least privileges. Because at least we have a high standard on security as we are dealing with HR data, and customer might be a little bit afraid what happens to those data. And that's why we decided each container should only get those privileges which he really needs. And this is getting difficult in EKS. Because in EKS you define I want to have 5 worker nodes, and you get those worker nodes based on EC2. Whatever on those EC2 instances happens, it's not up to you. So there could be at least this container or that container, and for EC2 you can only at least attach one role. So you can at least say what kind of role you want to attach there to get the right privileges. We started to say those EC2 instance does not have any access beside the attached role. So this means the EC2 instance itself has nothing beside attaching another role with least privileges. Now it is up to the developers to say this container should at least attach, or assume it is, not attach, assume the right role to get those least privileges. I heard about it. I was 2 weeks back on the AWS day. I presented the same, and at least I got feedback from it. And they told me, you know what? One day before I presented it, AWS announced that there is some new, I don't know whatever it is. I don't know if Kilian probably knows about it, but there is something, they changed something to also at least get this done, that you can really define role-based access per container and not only based on an EC2, and also at least helping us, the developers, to avoid that we need to assume right roles in our application, because this can lead to a lot of issues later when you're operating your application. If someone might change the role or the name of the role, then at least you might realize an issue that your container is not running any longer because he cannot assume the role, and this leads to a lot of issues. So what we did, we said, okay, let's start again and at least rethink how this could be done easily. And that's now the right side. So what we did, yes, we have still the Amazon API gateway in place. We still have containers, and we still have Lambda functions. But what's new, the orchestration of our services is now done by the Fargate. So we define a container. Out of this container we have a task, and out of those tasks at least we have a service. And those are at least combined with a network load balancer to make the communication between those different containers happen. But also at least we have the VPC link, which is the outfacing, or at least the external communication for at least everything which is coming from the Amazon API gateway. On the next slide, I want to go a little bit more into detail to really get the understanding of how is the traffic from Amazon API gateway coming to the Amazon Aurora database through the AWS Fargate service, because at least I thought it might be more difficult, but it isn't. But before we start with it, I want to go in a quick conclusion about the changes we did. So just my opinion, and I'm so happy that I guess Holger said it today more than once, just my opinion, but Kubernetes, or the aim from Kubernetes, is more for a hybrid cluster over multiple cloud providers. And for this at least, it seems to be really a good choice. But if you really want to go into a cloud native application, I don't think that you might be really happy with the Kubernetes, because you get different tools inside your cloud provider, which might be more in the integration to other services and also at least more managed by this cloud provider than your Kubernetes. Fargate serves, as I mentioned, a better and also easier integration into AWS services, and also for us a better security in terms of those role-based access. We at least also reduced a lot of overhead when we went through the Fargate, because no, we did not start to really think about what is the scaling of and how can we scale our Kubernetes cluster, what is about the airbag, how can we define namespaces, who is responsible for security and updates of the Kubernetes cluster, how can we test those updates, and at least something which is normally never the case when you're going more into AWS services. The Fargate service for us is so far, and we're looking back on the last 3 months, is way cheaper than going into EKS, because for EKS you have an, let's say, setup of 150 euro or dollar, I guess it's dollar, per month, only running those master nodes which you are not aware of and even cannot see. And also in terms of scalability, what we realized so far is the Fargate service a lot cheaper for us, because at least we can scale per container and not per EC2 instance. So we define on a container level what really is it about, and we only scale this simple container if required. Now, at least as I already mentioned a few things which I want to go a little bit more into detail, it's now the time for those. Hopefully everyone is still on the same level.
Yeah.
That's a different picture, but probably easier to really understand how the AWS setup looks like. Now at least I took it for instant feedback, but you can imagine for HLX it's exactly the same picture, but there's not a mobile app. On the left-hand side, we have a customer or even a mobile application, so web or a mobile application, which access our API gateway through the CloudFront. And this is something to point out here. Yes, we are really using CloudFront, even if our focus is on the DACH. We already had some customer in instant feedback, or still have some customer in instant feedback, which are heavily using the mobile application in Poland and US. And we also at least discussed with them the last months over and over again, what are we exactly changing and why. And one thing they pointed out to us was mostly like, yeah, we are quite happy with instant feedback, but honestly, it is so slow. And yeah, it is slow, because at least we are in Azure DE, that's Germany. You're sitting in the US and in Poland, what do you expect? There is no CDN. So yes, this takes a little bit of time, and this is something at least we also figured out now and said before we start, we will directly start with the CloudFront for making sure wherever this employee might be, he can at least access the application with best performance. The CloudFront divides into different types, even to point it out, and this is something I need to fix in the image, it's only one CloudFront. It's not two CloudFront, it's one CloudFront, but based on the resources requesting, it's going to an S3 bucket where we have a lot of static files like JavaScript, some images, HTML could be also there. So everything which is really static and not customer related is in this S3 bucket. And everything which is more data or customer related goes through the API gateway. The API gateway itself is secured by a web application firewall. So this is also something you're more or less getting out of the box. You just need to configure it right. And the Amazon API gateway is also at least combined with the Route 53 and the certificate manager for serving HTTPS, as well as with the Cognito service, as we are doing the multi-tenancy based on our Cognito service. So at least the Cognito service is checking if the user who's requesting data is really in this tenant, if he's logged in, if he's allowed to access those informations or those paths. Based on the path we define in the Amazon Gateway, Amazon API Gateway, there's one at least way where we're going directly to a Lambda function, and this Lambda function is getting the data out of the Aurora database, or at least for some different information, more from the web application, it's going through our VPC link, through the NLB, to the Fargate service in the back. And also at least those Fargate services can communicate with, for example, Amazon AWS Pinpoint, but also to mention all of those Lambda function and Fargate, they are encrypted. That's why I put it here, some other pictures like the secret manager and KMS. KMS is for making sure that everything is really encrypted. And the secret manager at least is therefore to share the credentials from the Aurora database, for example, Lambda or the Fargate. So instead of putting credentials into your environment, those services can request the secret manager for saying, hey, please give me the username and password and also the host from this Aurora instance. And then at least based on if we allow it in those Docker or in this service, he gets the credential and everything what he needs and can directly log into this application. This is also at least a good approach when you're thinking about changes on the database, no one of us at least knows the password of the database because we don't need to. We just generate a 64-character password and put it in the secret manager, and it doesn't care for us because we are not accessing those database. The only one at least, or the only services which accessing are out of AWS, and they can ask the secret manager. Looking on how this scales for all of our products, because as I mentioned, we are really in a way where we are sharing more or less the same infrastructure for our different applications. We have some general services like in Route 53 and CloudFront, CloudWatch, CloudTrail, which are out of the box and which are there to serve our infrastructure. So which really makes sure that we can use our infrastructure whenever we need it, for example, for a domain or for a CloudFront, that this at least works. For the application or the products, we have kind of similar, at least, starting point. So yes, out of any VPC, we have the CloudFront to serve our application in different areas all over the world. Based in the VPC only in Frankfurt, we are having at least 3 buckets. We have an API gateway. We are also having, for example, the web application firewall and some different services which are not placed in our VPC. And then at least in the availability zones, and to point this out here, everything which is in the availability zone is only within the private subnet. So we are not having any service in a public subnet beside the NAT gateway, which makes sure that the internet is redirecting through our, or at least that our private hosts can access the internet through those NAT gateway, but there is nothing more in our public subnets. So everything we are seeing here, like a Redis and Aurora database, Fargate services, Lambda, they are all at least placed in a private subnet. Let's go through how does really the traffic from, or a request from a customer coming through our API gateway to the dedicated Fargate services. Let's start on the right. So I will at least to quickly, I know I'm not allowed to go back. So now we need to go further. I don't know why. But at least hopefully you remind the picture. So at least we have dedicated Fargate cluster based on our products. So you can see here HTM stands for Haufe Talent Management, then this is an EF for instant feedback, and here it's HR Heads. So we have different clusters per product. The one instant feedback, the other one at least is HR Heads. On the next level, we have container, and which is quite important. Whenever you define the container, you need to define the port to access the container from outside. So this is here the, I guess, 9201. Remind 9201, that's the at least port we configured for this container. On the next level, we define the task, and the task is just how does this container really runs in our application. So what we define here is at least the use of the Docker container. That's what mentioned here. So this is just at least the Docker container we created recently, and then you define a little bit about the resources. For example, how many virtual CPUs, how many RAM can this container at least consume. And also you can start thinking about scalability here. But to define the scalability, we have the service. So in the service at least, we define also a load balancing to say how is the traffic coming to those different tasks and then through to the different containers. So what we define here is at least we define the container port, which is again the 9201, and we define the target group. This is just the name, which is obviously for us quite important to remind, but this is the name which stands for the whole service. So we have here the service, I guess it's the authentication service, yes, and we define a dedicated target group to say everything in this target group has to do with the authentication service, and everything which is coming through this target group is redirecting to one of those containers to the port 9201. That's what we define here. Also, at least you can define a little bit of scalability. On the next level, after you at least have the service defined and remind we had those target group, we define in the network load balancer a TCP port. This is again the 9201, which is easier to use through the whole story, the same port, but you can also use a different port, but then it might get a little bit difficult. So we have again the 9201, which we say gets forwarded to this target group. So this is where at least the scalability also starts, because it doesn't matter if it's 1 container, if it's 10 container, but at least important is everything which is coming on 9201 is redirected to this service, Fargate service. On the next, looking on the API gateway and also the VPC link. That's the API gateway, that's the VPC link. We defined an API gateway per product. So we can see again the Agile Heads in the instant feedback API. And based on this API, this is now here for the instant feedback, we have different routes or paths. This is the path for the authentication. And what we can see here is the only thing we define whenever a request is coming to this path, please use the VPC proxy. That's what at least, I guess I can also make use of this. Wow. That's at least the VPC proxy we defined here. The VPC proxy, to go into detail what does really mean, is just a configuration to say, please make use of a VPC link, and the endpoint to redirect your traffic to is exactly what we defined before in the NLP. So this is the DNS, this is the name of the network load balancer, and here at least, even if it's hard to read, this is the 9201 port with at least routing in the end. So that's how we at least get the traffic from the API gateway through the whole story till the latest thing, our little container in the end, which is also at least hearing to the port 9201. After mentioning how we at least get the traffic from the outside world to our container, it is also quite important to discuss quickly about security. Because when we also started this AWS journey with the Humantis, there were a lot of concerns regarding, oh, no, it's AWS, it is automatically in the US, and everyone can access my data. I don't want to go to AWS. And this is when we started, okay, now we need to define what is really in and what does security mean for us. So as I mentioned several times, these privileges on each container and service, which is one of the best things at least we can have in place. There is no IAM user in this whole environment. This is also something quite new, and we are hardly at the moment hard in the discussion with our at least landing zone team to make this more as a common standard, because this is really the case that there is not an IAM user as we as developer can log in through the SSO. So we are using our AD credentials, and the deployment which happens from outside the AWS account can happen without having an IAM user. This is really something cool, which I want to at least spend a few more minutes after this slide to really go into it. How can this happen to deploy an application from outside the AWS without at least having any credentials of your AWS account? There's no jump host. So as we at least, there is not an EC2 instance at all, because our application does not need any EC2 instance, and it also does not require any jump host. As at least we are using the transit gateway, so there is a dedicated line between the Haufe network and the AWS network, which is shared over the transit gateway directly in our private subnet. So yes, when we really want to get access to our private subnet, to the ADS database or whatever, we can at least make use of this transit gateway. This is only configured in the developer account. In our staging and production environment, there is not a transit gateway, as we do not want to have the situation that someone can really access the private subnet. Also mentioned, nothing is deployed in the public subnet except the NAT gateway. Without it, it would be hard to at least run the whole application. Everything, and really everything, is encrypted. So the ADS, S3, EFS, our backups, all the traffics between the containers, but also between the API gateway, the network load balancer, and also the container, everything is HTTPS. So this is also at least something we achieved. The credentials to our ADS database are only shared via the parameter store, so there is not an environment variable. And as I mentioned, even our developer does not know about the credentials. We are using CloudRail with S3 and Athena. This is also at least a topic which we can spend an additional hour. But this is also something really cool, because CloudRail is tracking what exactly is happening in your AWS account at the moment. Who is in this AWS account? Who is accessing what? And it is also quite easy to combine it with S3 and Athena to really track those happenings and record them, and also to send out alerts if there might be something which we did not agree on or we need to be aware of. The same is with the security hub. So we have a security hub in place together with the guard duty and the inspector, and there are also some more third-party tools you can integrate. Obviously, we do not integrate them yet, but we have a clue what we want to integrate. But at least guard duty is also quite good to get you the information. Hey, seems like there is a DDoS attack happening. Yes, you need to really see what is it about, because normally guard duty is throwing those information quite quickly, even if probably someone tries to log into an EC2 instance 5 times, and then you might get those DDoS attack already. But you can define and work on it. But it is also a good tool to really at least help your understanding security and also what's happening on your AWS account. The next topic, as I guess this is really quite or there might be some question, and I guess I also saw some fingers when I said there is not an IAM user. So let's go into the topic how we deploy the infrastructure. One thing quite important, everything is done in Terraform. That's also why no one of our developers has access to the staging and to the production environment, because this is really the thing where I want to have in place. If we give access to the environments, I know what happens. Oh, I quickly changed it. Yeah, and in the end, something breaks. So everything what we at least did is done by Terraform. We have 3 types of workspaces in Terraform. So we split our Terraform in environments, which are dev, int, and prod, or dev, staging, and prod. And for the different environments, we are also having different variables, which is quite important to really make sure that the configuration is accordingly to the environment. We are using 3 different kinds of accounts per environment. So we have a dev account where everyone can, or every developer can access. We have the integration account where no one of the developers has access, and then whenever we deploy something on the integration or staging account, we're getting the latest backup from the production account to really test if everything is fine, and if so, then things going into our production account. And this is the answer of why we don't need any IAM user or credentials, because we are using GitLab. And there's obviously one good thing, and now I need to be careful because there are people at least which operating this GitLab, and I know they are not so happy about those. But there is one important thing. You can at least get own GitLab runner and can integrate them in your pipeline. What we at least did is we pulled out some EC2 instances in a dedicated VPC, which is also quite important. We do not combine our runners with our production VPC or product VPC, but we have an own VPC, which at least is storing those 3 or whatever it is in the end, runners. Those runners at least have access to our GitLab in the Haufe through those direct connect and also through the transit gateway. So there's not a communication over the normal HTTP traffic. Everything is going through our dedicated line, that there is not something in the public internet. That's what I mentioned here with the direct connect. Whenever we at least run something from our GitLab, we don't need to access any IAM user, because everything which is deploying our product VPC happens from inside this EC2 instance. So at least this EC2 instance need to get the right rights, access rights, to at least deploy this product VPC, yes. But it is not about, oh, I need to share some credentials and how to rotate those credentials. I forget to update them in GitLab or whatever. This is not required, and obviously one of the best things at least we can achieve, because this is the only thing where we really can say we don't need any IAM users. And this is something we are also forcing or discussing with the landing zone at the moment, to really think about if there could be another way of providing those runners in our landing zone, so that the product teams can make use of it, and they also don't need the IAM users, because I know there are a lot of discussions at the moment about the new landing zone, and at least the situation that we do not want to have any IAM users in. This could really be an answer, and for us it is really running smoothly. How does those infrastructure look like? As I said, everything is written in Terraform. We have 3 different types of Terraform. The one is our baseline. The baseline configuration is really the setup of an VPC, the setup of security groups. We also at least have here an RDS setup in, because at least we also were thinking about to utilize the RDS on a higher level. This is something we replaced, so RDS goes for the products. But as we can see on the left-hand side, there are some configurations in VPC. We have a central AWS backup strategy for our products. We also at least configured the SES on the baseline. Otherwise, you need to configure it for every product, which is not the best thing. So you can configure it once and make use of it in the products. For the products, it looks a little bit different. The products at least make use of the baseline infrastructure. So they at least know the VPC and they can deploy within the VPC, but everything in this Terraform has really to do with API gateways, with certifications, with CloudFront, with Elastic Cache, with S3. So everything which is product related is defined here. And we have the same, or nearly the same, for our HR heads. Yes, some different services might be here, but also here at least we are having an own Terraform template for this dedicated product. In the end, this is how it looks like. So we have the base infrastructure to serve the VPC, security backup, SES, and yes, I put it security twice because it's important. And for the applications at least, we are having application-related services like API Gateway, Fargate, S3, and this is at least something which can scale. So whenever a new product might come, the only thing we need to do is to add a new Terraform and quickly pull out the new product there. Yeah. To go a little bit into the CICD approach we are following, I mentioned it, but I want to spend a few more minutes to go through it. We configured our GitLab in a way where it's not allowed to push directly to develop, staging, or master. So everything a developer is doing is done on his own or her own feature and bug branch. And whenever the developer pushes something there, we immediately run the Terraform validate for making sure whatever you're doing at the moment is still okay. If the developer decides on, I'm done, and now I want to merge my own feature or bug branch into the develop, he can easily do it. Create the merge request, but not merged by her or his own, so someone else needs to merge it. And while, or at the moment, you're at least raising the request, the merge request, we are also at least running the Terraform plan. Terraform plan is giving you the insights of what exactly is changing now the infrastructure, so that this person, which now at least confirms the merge request, already sees, okay, you're changing the VPC or the security group or whatever. If the reviewer agrees on whatever the changes is and click the merge button, then at least we are applying those Terraform changes on our dev environment. And if then, after, I don't know, a few days or whatever, can be immediately, the development team decides, yes, we want to have this on production as well, then they again raise a merge request from develop to master. And then at least a little bit more magic is happening behind the scene. We run the Terraform validate again, because it could be that there might be some other things happening, as it does not only need to have one merge request, so we can combine a few more. Then we run the Terraform plan. We apply our changes, but not to the production account. We immediately apply it to our staging account. And then we also automatically run the backup from our prod account into our staging account. So at least we get now both worlds combined, the new infrastructure with at least the existing data. And then we can do some testing, which is at the moment not only automated, but also for at least the product owner, product manager, whoever, to say, look, on the int or on the staging system, you are now at least able to see the existing data with the new infrastructure. If you're fine, then we click the merge to master, and then our changes really apply on our prod environment. Yeah, this looks a little bit fancy, but at least this is how it looks on GitLab. So it's just those three stages: we validate, we plan, and we apply. This is a merge into our develop. To get an insight, what is something at least we can see here. It is nearly the same story. We are having a GitLab, we are having our direct connect, we are having our runner VPC with some EC2 instances, which takes care of whatever we want to deploy. If at least we trigger our deployment process on the EC2 instance, the first what happens is the test and build. So we test our Docker container or the code, and then we build our image out of it and push this at least to the ECR, so to the Amazon own registry. If this at least is successful, then we deploy those new image to our existing Fargate service. We do then some integration tests And at least in the end, we check this environment again. What does the fifth check mean? In AWS Fargate, you have some different deployment strategies. So you can say, I stay with the existing one, I add some new, I immediately change the existing one and only go for the new ones. I have rated routing, so 80% still on the old, 20% on the new. So this is something at least we are defining here and making sure what's happening actually in our infrastructure. And in the end, if everything at least went well, then it's fine. If not, then we do a rollback, which is also automatically implemented in the pipelines, so that there is no need for a developer to watch what's going on and also to at least raise the rollback by his own. So this is something we also automated in this way. So quickly through the conclusion. Benefits of going cloud native. What I pointed here at least is, yeah, as more AWS or cloud native services you can use, as faster you get in realizing your business features. Don't think about backups, don't think about disaster recovery, don't think about scalability, or at least let's say it like this, yeah, please think about it, but don't think about it in a way where you really need to think how can you integrate it by your own. Think about it, how can you configure it in the right way. And this is really something fully different. Reduce the development overhead by really making use of services. So it's not only about the maintenance of the infrastructure, it's also about the way how you develop the application. And this is a lot easier if you really start from scratch and thinking about what can I make use of those cloud services and how can I integrate it in or my application. So for example, using Lumber instead of own Docker container is a way easier and a way faster to use than starting to define those Docker containers, to put them in Fargate, to define the tasks, to define the services. This is really a way easier. It is also a way better to handling and applying high security standards. So thinking about security in your own data center might really end up in some difficult situations. In AWS, you get a lot out of it. So you really can make use of it, make use of the guard duty CloudTrail to really track what's going on. And the thing, at least I also want to underline, Kubernetes is not bad at all, but it's different. And this is something which needs to be quite clear. So for us, at least, we decided it has a different purpose than going cloud native. Our aim is going cloud native. That's why we said we don't want to use Kubernetes any longer. And also to mention this, for example, at the moment we are working on the AWS AppMesh service, which is not that new, but still new for us, where we are also thinking about to really make a better service orchestration, not only within a product, so over all products we are having. And at least one thing quite important for me, and one thing we also realized, the big difference for cloud native application is really how they are built, delivered, and operated. What does it really mean? So the journey we also had with making use of Kubernetes, then realizing why we are using Kubernetes, there might be better services out of it to really focus our effort on the business feature side and not on the maintenance. So whenever at least you're thinking about cloud native, you should really start to rethink your existing architecture if there is one, and really avoid to just lift and shift the existing application, which at least would also work for us, but in the end at least we are not really getting the benefits out of the cloud. That's at least all from my side. Yep.
One question, is there a distinct reason you are using Terraform and not CloudFormation?
Yes, good question. The question is, for me at least, quite easy, because if you start using CloudFormation and Terraform, so make use of both at least, you might quickly realize that the support for developers, for example, when you're using IntelliJ, is much better than using the CloudFormation. And also, to be honest, you're having some different possibilities in going into the CloudFormation, into the Terraform, sorry. For example, if you're thinking about combining something with on-site in the Haufe, and we were also thinking about it, as we also had some configurations on the transit gateway side. So we started in the landing zone approach with this as well, and realized with Terraform you're having the possibility of also defining at least on-site infrastructure things based on virtual machine or whatever, vSphere, so you're not limited to AWS only. But to be honest, and this is the main reason, really make use of both. If you might realize for you CloudFormation is one of the better tools, then go ahead. For us, it was really that developer feel better using Terraform, also because you can make use of modules. So you can define your infrastructure in modules, for example, into AWS backup strategies, into SES, into S3 buckets, and can reuse your own, at least, infrastructure. And something, oh, I guess Kilian is getting nervous. I guess CloudFormation is having something similar.
That's a great feature, Cloud Development Kit, CDK.
Yes.
So definitely look into that because it solves some of the issues with IE support and targets and so on. You can really start programming your infrastructure similar to code.
Yes. Also something I guessed.
Actually translates into CloudFormation.
And honestly, in CloudFormation, you're, for example, also getting some better features for, how is it, drift detection, they call it. So if you want to see, is there really a change between what I created in CloudFormation and the actual infrastructure, there is also a better tool in CloudFormation than in Terraform. But as I said, in the end, you're getting the same thing out of both. It's just a way of what you think is easier for you or for the development teams to use. But there are slightly differences, yes.
You got a question for the development without IAM user?
Yes.
Because we're doing it a bit different with the Jenkins, probably some of us doing it. But if you accessing the EC2 instance from the GitLab in Haufe, you have the access somehow in the VPN, right? Or you have it in the direct access. So you have somehow access somewhere.
Yes. So the difference really is between AWS and Haufe. We have those VPN connection or even the direct connect. So we can really use the side-to-side VPN connection between both areas. And we combine or configure our EC2 instance to make at least use of GitLab. Oh. So it's the different way. We configure the EC2 instance to be a GitLab runner. That's the difference, I guess. I guess we need to close, otherwise, right, one is the next.
You have the next one.
Yeah, I know here, but this is the good thing. I can stay, but the people might change the room.
Other sessions ended, so...
Yes, but at least please come along when it really happens in GitLab. That's the validate. So you see it's just mentioning success. The configuration is valid. If this happens and we raise the merge request to develop or master, it doesn't matter, we get those kind of information. So in this, for example, this is what matters most. Plan says, you add 2 new things, zeros get changed and zeros get destroyed. This is really important for the developer to look into it, to make sure, please be careful, whenever you destroy something on production. As long as you add something, it might be okay. But when you destroy something or change something, please be aware there could be a huge impact for our existing environment. And this is what we get out of the plan. And if the developer says, yes, this is okay for me, then the only thing which is running then is those apply. And the apply is just taking those changes and applying them here. So we can see, for example, here we added 2 security groups, which gets here then created, complete after 1 second. So in the end, at least, we see the apply is completed, and everything we did is now in our developed environment. But this is only for changes on the AWS environment. This has nothing to do with the product deployment or our container. And for sure, there are some other services, to quickly mention them there. New for us, but honestly easier than operating it in your own data center. So yes, we make use of a lot of security tools mentioned here to really make sure that our application is secure and also to have the ownership of security of the application, but also some other services like Route 53. So we are at least owning our own domain. It's not like that we need to ask someone to add a subdomain or whatever it's about, to add an MX record for something. This is something we own the whole, at least, application in infrastructure now. After we started with this approach, and we were quite quick in those changes, I would say probably up to 3 weeks, and then we had at least the move to AWS mostly done. We realized one big issue in terms of our EKS. And this was more related to that we were not really happy about the integration of the EKS, but also realizing now it's not only that we need to operate our Amazon and need to be aware of updates in Amazon and how is Amazon doing. We also need to cover the whole stream about Kubernetes. What kinds of updates are there? How can we deal with it? What about the security in EKS? And then we also start to rethink